Welcome back. In this segment, we will focus on synthetic strategies. As you know, there have been many other topics covered that have helped us to make molecules, to modify the molecules, and so synthesis will continue to play an important role for manipulating organic structures to attain a desired outcome. What we want to understand, and actually previously a whole chapter was devoted to synthetic strategies. You may want to review that chapter. So since part of the discussion in this chapter has to do with epoxides, I had mentioned that these are very powerful intermediates. They're high in energy. They want to release the ring strain, and it can happen in such a way that we have nucleophiles. So that means they are an electron pair donor. They attack the epoxide ring. The strain can be released by opening this up. And then there is an intermediate that then leads to this overall outcome. It's important to realize that these functional groups are adjacent carbons. So this is basically a 2-carbon unit. So I'm just going to abbreviate that with C2. Now, whether you see 2 adjacent functional groups, whenever you see 2 adjacent functional groups, you should think of epoxides as a C2 unit you can incorporate. Here we have an example. Many of the syntheses can start with alkenes. This was a functional group extensively covered in Orgo 1 because it is so synthetically useful. Alkenes are more reactive than alkanes. They can undergo electrophilic addition reactions. Among the many reactions covered in Orgo 1, there is, of course, MCPBA. MCPBA is meta chloroperbenzoic acid. This belongs into a group we can also abbreviate as RCO3H. Sometimes you see this reagent in all caps letters. It's the same thing, MCPBA. The P stands for per, meaning that this has more oxygens. So this is not a typo, it's RCO3H. And that one oxygen is actually converted into an epoxide intermediate ring. So after step 1, we now get an epoxide. Remember that in the 3-membered ring, that epoxide has to be basically a cis, in a cis arrangement. We cannot accommodate a trans stereochemical outcome in an epoxide. So this has to be cis, so either up or down. And then, and we can also draw it flat because the product is drawn flat here. Then in the second step, here we have NaCN. You need to understand what this stands for. So this is Na plus and Cn minus. And we know that under these conditions with a strong nucleophile, the attack will now occur on the less hindered side. This opens up and is eventually quenched. You can also practice this with Skill Builder Review 13.6. These are really very, very important tools for you to learn and to deepen your understanding of the complex chemistry of organic chemistry. Okay, here we have another outline. So this is what we have seen before. We have a 1-2 unit, 1-2 unit. We can also do it the other way. It doesn't really matter right now. What matters is that this is a C2 delivery form or method. And then here I've pasted in again as an outline we had looked at before, earlier in the chapter. You can pause here. I recommend that. Go ahead and figure out what is NuC ... minus. So pause the video, look at the reagents in red, and figure out the group that is delivered with the first set of reagents in each case. Okay, so when we do that, we know that this is basically delivering us RO minus as a strong nucleophile. Here we have Cn minus. Here we have SH minus. Here, this is a Grignard reagent. We'll talk more about that. This Granary reagent will also come up in the organometallics chapter in a few weeks. This will deliver R dot dot minus. And LaH, lithium aluminum hydride, is H dot dot minus. So all of these have full negative charges, strong nucleophiles. And then you see we're always dealing with an alcohol that in the 2 position has a substituent. Maybe what I should do, just for clarification, let's get rid of these numbers here. And let's do this proper. Let's give oxygen the higher priority. So 1, 2, 1, 2. And now we see the 1 position here and how much flexibility we have to introduce new functionality. As simple as a hydrogen through hydride to an alkyl group from a Granary reagent to a thiol group in the 2 position, a nitrile, and an alkoxy. On this slide, we have a Granary reagent. Granary reagents are made by inserting magnesium into the RX bond. So we can have overall conversion, various halides. So after step 1, magnesium inserts into the RBr bond, magnesium Br. The overall result of this is that while here we have a delta plus and a delta minus, now this is a delta minus, this is a delta plus, and this becomes a delta minus. So this is also then an opportunity for us to think for this as a delivery system for a net R minus, and as a salt bipart, magnesium bromide. Magnesium goes from 0 to oxidation state 2. And so when we're looking at this will be overall positive 2 pluses, and 1 negative gives us an overall plus. And then we see that this is a strong nucleophile opening up. In this case, it looks like they added to the left-hand side, even though the molecule is symmetrical. This is opened up, forming an alkoxide intermediate that's quenched, leading ultimately to this product. So we can think of alkyl halides as starting materials, and we have grignards as strong nucleophiles reacting in here. Here we see additional outlines. There are actually 2 components here. The first example is how we can introduce a 2-carbon chain using an epoxide. And we see 1, 2. Here they changed the numbering again. It doesn't really matter, but just notice that this is coming from an epoxide. So in this case, it would be something like this. And then whatever, I'm very sorry, let me correct this. This is coming from an epoxide, which is shown here. And of course, the corresponding nucleophile is R minus, so Grignard is a great way for delivering that for the desired outcome. We can also utilize carbonyl compounds. A whole chapter will be devoted to aldehydes and ketones. We see here again that a Granary reagent is made. And then here we have, as an example, this is an aldehyde. We also abbreviate aldehydes as RCHO. We'll discuss that when we get to that chapter. The R group here is a methyl group. What matters the most is that oxygen is more electronegative. This is a delta minus. There's a pull in that direction. Here's a delta plus, which means that R minus will be attracted to that position. Okay, and I should probably, let me correct it again. So we have 2 R's here. So this would be CH3, CHO. This stands for acetaldehyde. We'll also learn how to name them. This is a 2-carbon compound derived from ethane. and the IUPAC name would be ethanol. All right, now we're going to take this one here. That will turn into an R minus. And now we see it takes 2 to tango. This will attack the carbon, open this up, and then quench. And then here we see our product. So you learn a lot more chemistry in that chapter on aldehydes and ketones, and it will be very helpful to understand the mechanistic background for making these bonds happen. All right, you may want to pause here, copy down the structure, and analyze what's going on. So we're being so the question, the task is here, what do we have to do? Doesn't tell you how many steps, but we need to understand what's going on in here. So obviously, we're going to look at what's the same and what's different. So the phenyl group here we have the phenyl group, which means we have to figure out a reagent that will add these components to it. How do you turn this into a nucleophile? Is one of the questions. And then how do you deliver this as an electrophile? So E, either delta plus or E plus, technically speaking. How do we introduce these 3 carbons? All right, the answer is on the next slide. Here we go. So we've added a 3-carbon chain. Here you see it numbered. We're making a Granary agent, which ultimately leads to formation of a phenyl dot minus as the nucleophile. So we're going to spend a couple of chapters on aromatic compounds. So this is our phenyl group. When we make the Granary agent, it's a delivery system for phenyl minus. It's attacking the epoxide on the least hindered side. It forms an intermediate that after acidic workup will lead to this product.